species.
Was there did we discuss a formula or something that told us how many total test cases you would need for something like paralyzed coverage given that?
We do not have a formula. Actually, as I mentioned, the problem of constructing the optimal coverage array is, we believe, no one has a formal proof. Okay? We believe, and it's very likely to believe, the whole community believes, is NP problem. And that means you really cannot find like a practical algorithm to do that. So because of that, we do not know what would be the minimum number of test cases you would have to achieve T-weight coverage. You could probably, in some cases, you could find a very loose bound, but it's not PDB. Yeah. Any other questions before we get started?
I got a solution for homework too. So after class, you can get 1 day.
Very good. So today we will finish JUnit. The project we're going to have, you have to use JUnit to do the project. So you're going to get a lot of opportunities to use JUnit. And if you have time, I think we're going to have time to get started on a new topic, graph-based testing. So, by the way, the midterm exam, okay, some of you have been asking, will cover up to and including graph-based testing. So when we finish graph-based testing, then we're going to continue to the next topic, but that's the coverage for midterm. I think maybe very soon we're going to face a date for midterm. Just to refresh your memory, what are the 3 major features of JUnit? The 3 things JUnit can do for us. Common setup, very good. Okay, that's one of the major features. Okay, what would be the second major feature? Assertions. Okay, assertions allow you to compare expected output with actual output. So you have to specify the expected output, but assertions make a little easier for you to do the comparison. Okay, for example, you do not have to have a loop to compare, like 2 arrays are the same. Okay, so it helps in that respect. What is the last one? Automatically execute the test methods that you have defined. So these are pretty much what JUnit can do for you. Okay, and if you look at how the APIs we discussed, if you look at the package structure of JUnit, they are pretty much organized based on these 3 features. Okay, and we're going to today we're going to continue to talk about the test runners, which are basically used to help you to automatically manage those test methods that you have. First finish So last time we have discussed the default test runner called JUnit core. Okay, and we have seen the demo that shows two ways to use JUnit core. One is that you're going to use it from the command line. You provide the test method, the test class as an argument to JUnit core. In that case, you're going to you basically use the main method in the JUnit core class. Or you can do it in your program, in your main method, in the test class. You can call the run classes method, and you can do the same. If you run the two different versions, you get the same results. So next, we're going to look at a test runner called Sweet Runner. Okay, it allows us to put different test classes into the same test suite. Okay. This kind of test management, because sometimes when you try to retest your system, for example, you want to always test those test methods in a number of test classes together, then you put them into one test suite. Okay. And this is how you use the test suite. You use this notation, annotation at run with. Okay, suite dot class suite is provided. That's the suite runner provided by JUnit. Okay, so basically, what this tells JUnit is that I want to use the suite runner instead of the default runner. Okay, then in this the second annotation, you're going to put different test class into this block. Then what you tell the unit is that all these classes, okay, all the test methods in these classes will be run together, okay, as a test suite. Okay, so that's basically what these two annotations do. And then you have a suite class. This is a placeholder, okay, and we're going to actually I'm going to show you the actual code. But here, this is just the like the test class. Like you could put a main method here, or you do not put anything here. In that case, you do not have a main method. You have to pass this class to the JUnit core class, so that you're going to use the JUnit core main method to run this. So I'm going to actually show you the actual code, and you can hope that will give you a better idea. So by the way, I posted all the code we use in the class on Canvas. So when you get the chance, just download the code and try to play with it. That will really give you a better understanding about how to use JUnit. And one thing I always tell my students is that I consider one advantage of computer science or software engineering is that you could easily do experiments, right? For free. Okay. If anything that we discuss here is not very clear to you, try to install the tool, download the tool, install the tool, try to play with it by yourself. Okay, it's not like chemistry, like physics, like biology. You know, like those kind of disciplines. It can be more difficult for you to do experiments. Sometimes can be expensive for you to do experiments. So I really want you guys to take advantage of this. Like there are many things that you just couldn't think of, like by reading it, and sometimes you have to take actions. You have to try it, and that's very easy for us to do. So try to do that as much as possible. So first, we're going to look at the SWIT test class or file. So can you guys see this from the back? Okay. So this is basically what I have on the slide. Okay. Now it's just in a .java file. As you can see here, and I have the two annotations. It's exactly as what we have on the slide. And so this is just the placeholder. Okay. You don't have to have the main method. Okay. So at this point, I commented out the main method. Okay. So you have nothing here. Okay. That's one way to use SWIT runner. So I'm going to show you how if you do not have a main method, you know you cannot execute this class. Okay. What you have to do is that you have to give this class to JUnit core. Remember, JUnit core is a facade. That's because you have the annotation here. So when JUnit tries to run this class, JUnit core knows that you want to use the SWIT runner instead of the core. So I'm going to show you the SWIT test. Okay. So if you look at here, okay. So the export the statement just tries to set up the execution environment. So this is how I use JUnit core, and I give the SWIT test class to the JUnit core class. It's basically execute the main method in the JUnit core class. So first, I'm going to run Java C. So I'm going to compile all the code in the directory just in case. Okay. And then what I do next is to run SWIT test. Okay. So basically the script I have just shown you. Okay. So as you can see here, yes, we get the same result because we only have one test class. You could put multiple test class here, but this is the same as what we have seen before. If we just use the JUnit core, the default one. Now we just use the default one. You could put multiple test classes here. So this is one way to use it. Another way to use the SWIT runner is that as we mentioned, I could have a main method here instead of using the main method in the JUnit core class. So here, now I have a main method. Okay, this main method is pretty much the same as what we had before, right? You just pass the SWIT test class, this is this class, okay, to the run classes in the JUnit core class. Okay. And you get the results, and you get the failures, you print out the failures. Okay. So, so I'm going to save this one, and I also need to go back to the script, run SWIT test. I have to use, in this case, I'm going to directly execute SWIT test yes.
Is there a guaranteed order that the classes within the SWIT run in?
You mean the SWIT, if you put multiple test classes? I don't know. I would, maybe you could try it. That's a good example that we want to do experiments on that. As we mentioned before, the multiple test methods in the same class, in the same test class, they are not, they are deterministic, but unpredictable. I'm not sure if that's the same case when you put multiple test classes together. So something to try and find out. If someone could do that, do the experiment, tell us next time. Good example, good question. Okay. Yeah, this really depends on the designer. There's no general, you know, principle that they have to follow. So I think we have to find it out either with documentation or through experiments. That's a very good question. Okay, so now because I have a main method, then I can directly call this method, this class, and execute this class. Okay, so I'm going to save this. Okay. So what I have to do next, first I have to recompile all the code, right? Because I changed the Java file. Okay. So I'm going to compile this one, and I'm going to re-execute the script. Now I'm going to execute the Sweet test class. Okay, so you're going to get basically the same. Okay, and then to show the difference, as you can imagine that because we do not really show the statistics, because that's what we have seen earlier, right? So you can see this is different, but you can also print the same information. Okay? That's the second way where you use Sweet runner. Okay? Any questions before we move on to the next test run? Okay. So let's say I'm going to switch back to the slides first before we come back to the programs. The next runner is also used a lot. It's called parameterized runner. Okay. It allows you to have tests that are parameterized, and you can take different parameters. So I guess to understand the motivation of having parameterized runner, I'm going to switch back. Okay, to the code. Okay. For a moment. It's a triangle classification. This is the test class we have. Okay. So these are the test methods we had, right? Remember the triangle classification, for each type of triangle we have a test method. Right. Now we have check invalid, check staining, check isosceles, and check equilibrium. I want you to look at this method. Okay. What do you feel? Is there any kind of redundancy that we may be able to get rid of to make the code like more concise? If you look at these three methods, do you see any kind of redundancy?
We instantiated a triangle with every one of them.
Okay. So from a certain perspective, if you look at the three methods, they are pretty the same method, but with different parameters, right? Different inputs. If you look at this method, check invalid, they just take. If you look at this one, the only difference is 3, 4, 8, and 4, 5, 6. Of course, the expected output would also be different, right? But as you can see, they are pretty much similar, and that's what the method is supposed to do, right? Like if you think about the regular Java method, you have the same code but have different parameters, right? Why don't we do that to the test methods, right? We don't have to have a separate method for each test case because they are pretty much similar. The only difference is they take different inputs and the expected outputs, and the expected output could also be a parameter that we provide to a, let's say, conceptually speaking, a meta test method that can be instantiated to different test cases. And that is the motivation equation for the parameterized test run. Okay, so keep this in mind. I hope that would help you to understand what we are doing next. Okay, so I'm going to switch back to the slide.
So what's wrong with this?
What's wrong with this? Anyone can respond to this question. What's wrong with this?
You use a repeated method again.
Yeah. Anyone has an opinion? How to answer this question? That's a good question. What's wrong with this? Why don't we just keep this, right? Why we want to have a different way to do it? Anyone has any opinion on this? What's wrong with this? That's a good question. Okay, I don't know if you guys heard about it. Whenever you try to do something different, you ask the question, right? I mean, what's the why you have to do what you want to do? Okay. See, the answer is that there's nothing wrong with this. Okay, it's just if you have 100 test cases, you have to have 100 test methods. Okay, so it's kind of, I would say, less efficient. Okay, but it still works. But the code is going to be, you actually write a lot of test methods. It's kind of repetition that you could get rid of. It could be more efficient, more concise. Because later you will see, we will only going to have one method. Okay, have 4 different groups of parameters. So you're going to see the difference. Okay, and so that's what we are trying to do. It's not anything wrong with this. It's not just not that efficient, okay, from a certain perspective. From the compile time perspective, okay, the runtime is the same. All right. Okay. So this is another example. Okay, we're going to come back to the triangle classification where I do the demo, where I switch the laptop. But here we have a different algorithm, okay, a different example that you can see how we use the parameterized test run. Okay. So here the annotation, we have one new annotation to indicate like this 2-dimensional array will be used to supply the parameter values. Okay. So as you can see here, this is kind of a 2-dimensional array. Each like a pair here we have 1, 2, 3, 4, 5, 6, 7 pairs. Okay. Each pair will be used as a group of parameters to instantiate this test class. Remember, as I mentioned before, so when JUnit executes a test method, it will always create a new instance of the test class, okay? Because you don't want to have interference, okay, between different test executions. That makes sense. So whenever JUnit executes a test method, JUnit will always create an instance of this test class, and that means JUnit is going to call the constructor to create an instance. Okay? So what the parameterized test runner does is that each time when JUnit tries to create a new instance of the test class, it will use this, in this example, these 2 values as the parameters of the constructor. So basically, when you run this parameterized test, I would say test class, okay? Basically, you are going to create 1, 2, 3, 4, 5, 6, 7 test instances. Okay, so how it works is that first you take these 2 values as the parameters of the constructor. Okay, so it's going to assign 0 to this member, to F input, and the expected output
to this data method. Then JUnit is going to call this method. Okay? So as you can see here, you basically, this is the input. I guess you can guess this is a Fibonacci computation, right? If it's 0, and this is the expected output. Then it's going to execute, you're going to give 0 to this compute method, and you're going to check the return value is expected or not. If it's 0, the expected Fibonacci number will be 0, right? So that's one test method. Then what the test JUnit does is that it's going to take the second pair, okay, in this array to create a new instance of the test class, which would be 1, 1, okay? Then after you create this instance, then JUnit is going to call, going to execute this method again with these two parameters, okay? And it's going to check whether the expected output is the same as the actual output. After that, JUnit is going to do another one, okay? It's going to create a new instance with 2, 1, and it's going to execute this test method. So as you can see here, what we have, if we do not have parameterized test runner, then what you have to do is that you have to create 7 test methods. Okay, each one with a different input and expected output. But here you have one method that can be instantiated with, can be executed, not instantiated, can be executed with different parameters. And that is the basic idea of parameterized test run. Okay? So what's important is that you need to use this annotation to tell JUnit that these values are the parameter values that you are going to use in execute the test methods. So this one test method is basically like 7. Okay, you could put more. Okay, like 7 different test cases. Okay. And we're going to see a demo as well. Okay, but for now, let us look at this from a conceptual perspective. And another way to use, okay, parameterized test runner is that you're going to get rid of the constructor, okay, okay, and you're going to directly tell JUnit that this data member will get the first value, the parameter value you're going to pass. Okay. And the second one will get the F expected, will get the second value. So basically tell JUnit how you're going to pass the parameter values to the test class. Okay. Then this is the set. So it's just like a kind of working way. You don't have to have the constructor, but at the runtime they are the same. Okay. When you use these annotations, when you execute, JUnit is going to do the same thing. It's going to construct. Basically, JUnit is going to do the construct for you. Okay. But at runtime, they are the same. So let me come back to the laptop. I will show you how this works with the triangle classification example. So this is what we had before, right? I have like 4 different test methods. Okay. So now what I'm going to do is that I'm trying to have one test method with 4 different sets of parameter values. So which would be parameterized test. So as you can see here, I'm going to use the run with annotation tell JUnit. I want to use the parameterized test run. Then here I specify the parameters. Okay. that I'm going to use for the test method. And as you can see here, again, like it's a two-dimensional array. Each one-dimensional array here represents the parameters that I'm going to use to execute the test method. So as you can see here, this would be the three integer values that represent the three different sides of the triangle, and this would be the expected output, right? So I have the invalid, scaling, isosceles, incremental. Okay. Then what I have here is that I'm going to tell side 1 would be the first value in that array.
Is it
One time.
input of incorrect? No, it's not right.
See that again?
Go back. The last one.
The last one?
Yeah, the input.
Oh, okay.
I think it's right.
Yeah, I don't know why. Okay, very good catch. Yeah, I don't know why we have 8 here. Yeah, very good catch. Okay, so here you basically specify the first value would be assigned to site 1, second would be site 2, third would be site 3, the last one would be the expected output. Okay. And you have the test method. Now you can see you only have one test method instead of 4 different test methods. Okay. And this test method takes the parameters site 1, site 2, site 3, and the expected output. And that's the difference between like using parameterized test runner and the default test runner. The default test runner you will have 4 different test methods. And as you imagine, sometimes when you have many like you want to try different inputs, you will have to write many test methods if you use it. So it's again, it's a kind of a convenience feature. Okay, it's not something that you have to have. You could do without it, but this one is going to be more convenient, okay, more concise. So then let's see how we're going to run this, right? Hope that will work as expected. Let's see. So I'm going to show you the script. So you can do the same thing again, okay? But here I'm not doing the both ways. You could write from command line, or you could use the Java API. Because you use the run classes API. Okay. So here, because I don't have a main method, you could have a main method as well, the same as for the other runners. So I'm just giving this test class to the JUnit core class. Okay. So what I'm going to do is that first I'm going to run, going to recompile all the Java code just in case the may not be consistent. And then I'm going to run parameterized test. Okay. And you're going to get the same result. Okay. So you still get like 2 pages, even though we only have one test method instead of 4 test methods. Right.
Totally different, right?
The order is different.
And because you are only one test, you are only one test method, so it is follow the giving
Okay.
order.
Okay. That could be very,
Yeah.
very good. Very good observation.
0, test 3.
Right. So
You
test
can-
0, test 3. So I guess his point is this. Okay. If you look at the code. So now with the parameterized test runner, it will always execute in the order as we specify here. Okay. And that's a little bit different from the default runner when you have 4 different test methods. Okay. I think that makes sense because this is kind of deterministic. The array, the values that appear in the array at runtime is kind of fixed. Okay. Not like the test methods, they are like the order, because you define that is a compile type. At runtime, they could be executed manually. But very, very good observation. That's why we want to do experiments. It helps us to discover things that we're not sure without running the code. So that's the parameterized test runner. I think I hope it's kind of simple concept, right? That's a very general concept when we write programs, right? If we have similar code, just take different inputs. You don't want to repeatedly like define different methods just for different inputs, right? You want to have one method that could take different inputs. So the same concept applied to the test methods. I hope it's kind of QAP. Any questions about the different runners? There are other runners available in JUnit, and JUnit also allows you to write your own test runner, provides interfaces, allow you to do that. But I would say in most cases, okay, you are probably going to use one out of the 3 runners we discussed. I don't want to get you confused. There are some advanced test runners that are available, but I think in most cases you have to use one of them.